Welcome back. Take a couple of minutes here, and this actually probably is a couple of minutes, maybe not as many as the last one, and look at TCP versus UDP. And here we're at layer 4 of the OSI model, the transport layer. So these are layer 4, transport, or host to host, TCP IP model, host to host. Protocols that we're talking about. They're really important, but TCP is the reliable, called reliable frequently, or reliable. The term that I prefer is connection oriented because we talked about that, we'll talk about it again. UDP unreliable because it doesn't do any of that numbering system that we talked about. We'll try to look at some of the headers on these things, and it's also called connectionless. So the two major protocols working with IP, the layer 3 protocol, TCP transmission control protocol, and user datagram protocol. TCP reliable because it has sequence numbers and acknowledgments. We talked about those. Retransmissions, if something doesn't get there, if it's not acknowledged, then it will be retransmitted. Puts a byte stream into segments. Remember the PDU, the protocol data unit for the transport layer was segments. And to do those again in the don't some people fight back data segments SEGMENTS. Some people, that's a P, packets, frames, and then bits. And this is the OSI model layer 1, 2, 3, and 4, which would be the transport, network, data link, and the physical. So when you, if you ever need to know that, don't some people fight back data, segments, transport layer segments, PDUs, protocol data units that are used at the different layers. So puts it into segments. Application does not chop the streams into packets. Flow control devices operate at different rates. So what we will do when they operate at different rates is we'll agree on a window size. Let's call it window size. We'll look at a packet here in a minute. Window size in order to determine how much data can be transmitted at one time. We don't actually acknowledge every segment that goes out. What we do is put the segments into what are called windows. And one of the things to think about that, it's kind of the difference between a bus, a physical bus, where you put a bunch of students on. If you're going to take students on a field trip, you're going to put them on a 52-passenger bus, and each of the students you can kind of think of as maybe a segment. And we do that so we have a 52-passenger bus where we get 52 kids on, or we could do a car where we could do like 4 maybe. We're going to be able to put them all on and keep track of them in the school bus. Whereas if we put them in cars, we'd have to have a lot more tracking going on to be sure that all the kids got there at one time. I want to start, so that I find it, a little demo on the sliding window to give you an idea of what that's like. So what I have on the screen right now is a demonstration of the windowing or the sliding window as we go down. If we start this thing right now, we're going to acknowledge 4 packets at a time, and we have a 0% loss. So if we start this thing, ABCD gets sender to receiver, and then it comes back down, and they get acknowledged ABCD, and the window moves as the data gets acknowledged ABCD on down. So really a great one there. Let's go on a restart and let's say, let's make us have a 20% loss here so that we can see what happens. If it will start for me ABCD, we go on up here and goodness, all of them get acknowledged, so we go on over. ABCDEFG, they get up there. Not everything gets acknowledged. So you notice that it didn't run very far. I guess it jumped on me real quick there. Acknowledge. Let's try that one again. Let's do a stop. The loss is that's what should happen there. We didn't get the acknowledgments. It didn't like my restart. So finally, we're getting data here that's not being acknowledged. So we go in. So we finally did get everything acknowledged in these things. So it will move when it gets all of the information. So we finally got a transfer complete. Try to start here. See if it will do what it's supposed to do. Yeah, that's what it was supposed to do. It only moved over one because we didn't get an acknowledgement of B. Now we finally got all of the acknowledgments. So it's going to only move the window size at the rate the acknowledgments come in. So puts a byte stream flow control, the sliding window, how it works. Multiplexing, we talked about port numbers, but again, port numbers, and they become kind of not kind of, but they are a big deal. Each of our systems is going to have a port number. It's going to have an IP and a port number. Our sending is going to be an IP address of our machine, and then it's going to be a random port number. The destination is going to be what's called a well-known port. The well-known ports come back when there were 3 computers in the world, and somebody wrote this cool program called a web server, and he said, okay, it's going to be available on port 80 at my IP address. So the IP address and the port number becomes a socket again, so that we can get something from that location. Sliding window port numbers. Port numbers represent applications that are someplace. If you go to different port 80s, because the destination port is going to be port 80, the source is going to be different. It's still going to be our IP, but it's going to be a different port number here, and they'll go to a different IP and port 80. So we're going to have different connections available to us in this connection-oriented world to allow us to do duplexing. Port numbers allows us to have different things open, multiple things open at the same time. Connection-oriented, we talked about that. It had a 3-way handshake with the SYN, the SYN-ACK, which is actually an ACK-SYN, and then a SYN, to establish the connection. Once we do that, all we should see is ACKs, ACK, acknowledging receipt of the data. And the full duplex, interstate highway, we can transmit and receive at the same time. We don't really have any restrictive bridges, I guess, in there. What I would like to do, let me drag this over here. This is a Wireshark sniffer, which you can get online. It's free, and I would recommend that you do that in order to be able to try things out on your own. So in this thing, so what we have here is TCP, SYN-ACK, and ACK somewhere in here. here. We have a SYN. Here we go. SYN. The sequence number 2584941. They say 4919667. I told you they're quite a bit bigger. We send this here. We have the sequence number here in the SYN, and then the ACK and the ACK in the SYN-ACK is one greater than this. And then the station that we're going to sends its own sequencing number, its sequence number, and then we ACK it. Here's 663 with a 664. The window size here, proposal, let's see, 1460, and then he wants an 8192. We'll wind up here with a window size. They agree upon a window size. Port numbers here, they're going to be, it's a source 192.168.100.150, and my port number is going to be 56744, a random port number. The destination 13.107.5.80, port 80, is going to be the destination, which tells me that I'm going to a web server. So I'm going to have a connection-oriented TCP connection to get to a website. When we do these things, we just go down to TCP, HTTP. We got the GET command, TCP, acknowledge sequence number, whatever, and the sequence number is incremented based upon the amount of data that you receive. Sequence number, and then acknowledge the sequence number for this packet, and then acknowledge TCP. Let's see, 192.150, 13. It is sending it back to me. So the source from coming back is port 80. The destination is my port number. The port numbers are changing here for different connections that we go through this thing. But Wireshark, and then the things that are going to be in, and you can go down here and open up each of these things. So layer 2, the Ethernet, the destination. We have the MAC addresses in here, and this is what a MAC address looks like. The reason it says Dell here, the 002219, is the prefix that's assigned to Dell. So we have two halves of it, the organizational unit identifier, and then the serial number that goes with these things. You can look all those up if you want, but that's what a TCP packet looks like when we do these things. So multiplexing, connection oriented, full duplex, reliable, or connection oriented. Reliable because we have the sequence numbers, the acknowledgments, and then retransmission of any data that wasn't received. Again, this is the same images that we looked at in the previous segment. But the SYN, the SYN-ACK, and then the acknowledgement of what goes on with it. And over the other one, we have the packets we're going to receive. We have loss. We keep going until we actually acknowledge receipt of it. So it accepts data from the upper layers, breaks it into smaller units known as segments, the transport segments, the protocol data unit. It passes these segments to the lower layers that ensures that all segments arrive correctly at the receiving end, because we number the systems and number the segments, and then they get acknowledged by the receiving station. Sequence number to each segment helps reconstruct the original sequence. If they are received out of order, they can be put back into the proper order. Responsible for error correction, sending acknowledgments at the network layer. So we're going to do those things. This is what the TCP header looks like. We have the source port number, 2 bytes, the destination port number, 4 byte or 2 bytes. These are going to be obviously 4-byte segments here. The source port number, a random port number, ephemeral port number you may hear. The destination is going to be a well-known. We have the sequence number, the acknowledgement number, and then some the data offset, if there is any. The control flags, what type is a control flags? Be like the SYN, the SYN-ACK, and the ACK. The window size, how much data are we going to send at one time to be acknowledged? A checksum, and then an urgent pointer. what the urgent pointer says is don't cache this thing until we get a full window. Go ahead and send the data. And then there's some optional data down there. UDP, connectionless, no acknowledgments, small packets. Streaming applications are typically going to be used there. Can you imagine if you're trying to listen to stream a video or stream a song, if you had to wait for the acknowledgments, what's going to happen? What kind of jitter, and jitter is going to be inconsistent delay and delay that you can get. Go over here again. I'm going to bring Wireshark back and see if we can look at a UDP. We have a UDP. Let's see what we have here. 192.168.100.1. Link 60. We have our port numbers here: 46.829.10.111. In this thing, Internet IPv6 UDP, the source port and the destination port, and then the data that's going to be in here. We can also look here. This is a DNS query, but you notice there are no sequences number. There's no SYN/ACK, and ACK, and any of that other stuff. No sequence numbers in here. It is a much simpler protocol. It does not do any error checking. There are no acknowledgments. It is connectionless. What's responsible for the data is typically going to be something at a higher layer, the application layer, for instance. If you use a TFTP server, Trivial File Transfer Protocol server, to download things, it doesn't. It's a very simple protocol. It only does its actions, but the application itself, the TFTP server program, will tell you if you have some error, if you have issues with whatever it is that we're using. So the UDP header, a 16-bit source port number and a 16-bit 2-byte destination port number. UDP length, the 16-bit UDP length, how the length of what's going on here, and then we have a checksum in this thing, and then the data is going to be attached to it. Very simple header, very simple protocol in it. A comparison between the two protocols here. General description: UDP, simple, high-speed, low functionality wrapper for IP. The TCP, full-featured protocol, reliable because it has a numbering system. Connection setup: UDP is connectionless. TCP is connection-oriented. We talked about the three-way handshake. Data interface to the application: message-based discrete packets, whereas the TCP is stream-based, puts all of the data together, sends the data without regard to the structure. Reliability and acknowledgement: UDP is a best effort protocol. TCP is the data is acknowledged. Retransmissions: TCP, they're not done. There aren't any. TCP, the missing is resent. Data flow management: UDP, there isn't any, and TCP uses the sliding window. UDP has very little overhead. TCP, the overhead is low, but it is higher than UDP. UDP is a very high transmission speed. TCP is going to be high. Data quantity: UDP is small to moderate, and then TCP can be used for a small amount of data to a very large amount of data. Some common ports that are available for each of these 20 and 21. TCP is going to be FTP file transport. 22 TCP and UDP for SSH. 23 TCP, and on down the line, if you want to do these things, you can pause the video and take a look at these things. And it represents the application layer services used in the access lists to restrict access. So if we wanted to only allow certain machines, and we'll do access control lists to do certain things, certain accesses, only allow different port numbers, different applications through a device, then we can use that in the access control list that represent the application of the services that are running there. So, in summary, TCP was the more complex header, reliability, connection oriented. We had the SYN-ACK, and the ACK, and we used port numbers in order to use port numbers in both of them. The port numbers in order to get to the application. It used the three-way handshake again. It used acknowledgments to ensure reliability. UDP was connectionless, had a small header, and no reliability at the transport layer at this particular part of the header itself. Something else typically at the application layer would be used for the reliability. So that is a comparison. Compare TCP and the UDP protocols. The next topic is going to be the impact, as I described, the impact of infrastructure components on the enterprise network. We'll talk a little bit about firewall access points and wireless controllers. Hope to see you there.